Hello, I'm Paul Beckwith, University of Ottawa Laboratory for Paleoclimatology, and my website is paulbeckwith.net. Please have a look at it. If you Google Arctic sea ice graphs, you actually come to this particular site. And there's loads of data here. There's blogs, forum, lots of images, lots of data here on the Arctic sea ice, which is what I'll be discussing in this video. I'm going to look at the sort of my assessment as to whether we have a blue ocean event in the Arctic in the cards. A blue ocean event being, say, less than 1 million square kilometers of sea ice at the end of the melt season. So what you see here is this is the Arctic sea ice volume in 10 to the cubed or 1,000 cubic kilometers, and it's for each different month from 1979 to present day. Okay, the average, this was updated February 2016. So here you see the September sea ice trajectory over time, the spiral towards the center, so 0 would be no sea ice. And you see that there's a decrease, and we reached a minimum here in 2012, and there was another minimum in 2007. And I'll look at what's happening this year. Now you'll also notice that each month of the year is showing a decline of sea ice volume. So the ice is getting thinner, the extent is getting smaller, the area is getting smaller, everything is decreasing. And where is that going to take us to, and how quickly? If we display this data in a different format here, so what we have is the Arctic ice volume fitted to an exponential curve, and again it's for each different month. So this is the average ice volume in a given month. So this would be the average in September here, the lowest curve. And then bracketing it would be August, which is the pinkish curve, and October, which is the purple curve. So what this seems to indicate, and then so on for each of the different months. So what this seems to indicate is when this curve reaches essentially 0 in September, then the other curves follow down. The other curves follow down pretty quickly. So you could imagine no sea ice, blue ocean event in September, and then within a few years, these other two curves, I'm just bracketing it, come down to 0. And then as time proceeds, the other curves drop to 0, and eventually can we reach a state where there's no Arctic sea ice year-round? And we'll have gone through an abrupt climate transition if that happens. Okay, so what I'm going to show now is this is the yearly minimum Arctic ice volume over time. And this is fitted to a linear curve instead of an exponential curve. And this is what we have here. So we had a minimum in 2007, another minimum in 2012, and this is where we've been in the last couple of years. So we'll have a look at what's happening now. So again, if you just Google Arctic sea ice graphs and come here, then you can see the this data is updated as of today, yesterday. Okay, so it's constantly updated, and this is the sea ice concentration in various forms. We have the Arctic sea ice extent. This is the National Snow and Ice Data Center. Now, the problem with this particular data from the National Snow and Ice Data Center is that they had a sensor that was experiencing difficulties, so they suspended the time series. This happened on or about April 5th, and they're working to fix that problem. But we do have what happened is it seemed to go into these oscillations, similar to what we see here with the cryosphere today data. So I'm assuming that this data is from the same sensor as the Snow and Ice Data Center sensor, but I don't know that for sure. If it's not, then, is it possible that the sensor, because of the state of the ice, it's messing up the sensor readings? That remains to be determined. Probably not. See, this is the sort of thing that was going on with the data. So presumably this is from the same device. So we're going by the JAXA, the Japanese Sea Ice Extent. So if I click on here, this shows you what the latest value is of the sea ice as of April 26, 2016. So this is the red curve that we're looking at here. Okay, so you can see that we're well below. We've got the 1980s average, the 90s average, the 2000s average. We've got the lowest year was the blue curve. Lowest year was the blue curve there. Okay, if I can get it. Okay, there we go. I'm not sure why I'm... Okay, so this is the blue curve. That was the lowest year in 2012. And then if we go to the green curve, is the next lowest year in 2007. And then the third lowest year was 2015. And here's where we are now. So we're well below any previous year for this particular time of year. We just crossed below 12.57 million square kilometers. And if you compare to, if you go out to a level here in 2015, when we were at 12.57, roughly, it was May 4th. Okay, so we're at least a week, maybe a bit more, ahead of the previous lowest year, record year. And if we compare it to, other, like 2007, we're even further ahead. We're way ahead on the averages. So what's happening is, one of these years, depending on the conditions or so on, this is going to head to essentially zero, which is what I'm calling the blue ocean event. So if we go back, if you want to see what's going on with the planet, because of the rapidly warming Arctic, we're seeing the jet stream. This is Earth Null School. If you Google Earth Null School, and if you go to 250 millibars in the atmosphere, this is where the jet streams are. You're looking at winds. Then you can see the nature of the jet streams. So this is Greenland up here. You can see that as the Arctic is warming, the waviness of the jet streams gets much more intense. It's fractured. There's vortices breaking off of it. It's basically a big mess, and it generally separates cold, dry air in the Arctic from lower latitude air, which is warmer and more humid. If we want to look at what's happening sort of day to day or get a week forecast, you can click on or Google Climate Reanalyzer, and then you can see what's going on today. Okay, so this is a temperature anomaly, and if you click on here, it moves you around, and you can see the temperature anomaly, which is the temperature today relative to the average. You can get it on a global map here, and you can see that the Arctic is 4.15 degrees Celsius warmer than normal. This is becoming an ongoing feature, which I'll show here. So going back to Arctic sea ice graphs, if we go down, okay, so we looked at the extent dropping. The extent is any area where there's 15% or more ice. And you can go down and have a look at these different curves, and I'll just point out a couple different things. First of all, this is the daily mean temperature in the Arctic, and this is data from 58 to 2016. Now the ERA 40 curve, if you go down, It's the mean temperatures for the period from 1958 to 2002. It's using the ERA 40 data set from the European weather forecast system. So this is like the mean, and this is what we're seeing in 2016. So if we look at the temperature here, the average temperature here might be 252 Kelvin versus 243 or something. You know, this is like, if this is 243 and 252, it's almost 10 degrees Celsius warmer. And that's all of this year. And we're still climbing here. So we can see, you can see that what's happened in previous years. So in 2015, we were warmer over the beginning of the year, and then it kind of stabilizes at the usual temperatures in the summer, and then in the fall it's much warmer. So this is a pattern that we're seeing, very warm winters. Summers aren't as different from the long-term average. So this is 2014, same data, a lot more fluctuation. 2013, and this is 2012. So you can see that this is where we had the record minimum of sea ice in the summer. We were well above, and you can go back and you can look at particular years. So even back in 2007, we were getting temperatures in the beginning of the year and at the end of the year in the northern hemisphere. So this is in the winter, temperature anomalies above average. So this is not good for the sea ice, obviously. Let me back through here. This is another plot here, which is interesting, and this shows a similar thing in the data. So this shows the air temperature over the Arctic Ocean. We can get the 2-meter temperature, and you can see that it's much higher than the average. And if you look at the freezing degree days, you can see that they drop off. So the Arctic has been much, much warmer than normal. Of course, it's no surprise that the sea ice is taking a big hit. And if we look at what's happening with the actual movement of the sea ice, the drift, what you can see is it's very dependent. The sea ice export is very dependent on these types of patterns. So the ice is moving very quickly here. Go back a bit, and you can see that there's a lot of export here because of the cyclonic patterns that are moving through the Arctic. So the conditions of the weather conditions are, here we go. So look at this. This is a low pressure area. We get this rotation here. We get export of the sea ice there. We get the bearing. We get the circulation here in the Beaufort gyre type thing. And so it's pulling the ice away from the edge there. So we can go back to here, and we can look at what's happening over 12 months with the sea ice. So you can see that this is the thickness of the ice. So we're going, this is in 2015, 07, 18. So we're into August 2015, and the ice is going down to its minimum, sort of mid-September. And then the ice is growing back through the winter, but because the winter is so much warmer than normal, 5 degrees Celsius more, the ice formation is less, so the peak was much lower than normal. The ice is not as thick, it's not as strong, it wasn't as extensive, and now we're coming into February of this year, March, and you can see the export picking up, dependent through the Fram Strait, dependent on these cyclones, and there's not a lot of thin ice in the Arctic there. So the big question is, I'm going to have to end this video and do a part 2, and I'll discuss what's happening with this blue ocean event. So please bear with me. Thank you.